So welcome back to the second session. So this session is going to be very short. So it'll be about 20 minutes. We're going to talk about breadboarding. So breadboarding is in the chapter about Introduction to Circuits. So when you're building circuits, you have basically two main choices on how to do it. The first phase is usually the prototyping phase where you're testing things out. And you'll use a breadboard because it's an easy way to make certain circuits and to make changes and to test things out. And then when you're satisfied with your design and you fully tested it, that's when you typically would go and solder a more permanent version of your circuit. So for prototyping, we have the breadboard, and the breadboard I'll hold up. So each school will receive 42 of these, so each student will have their own. So the breadboard consists of interconnected metal electrodes. So these connect different pins together on the breadboard, and they're organized in a very specific way. So this is the back side of the breadboard. If you ever peel back this insulation plastic, which you shouldn't do, you can see what the connections are behind it. Let me first talk about how you should hold the breadboard. So the way it's numbered, you would think you should hold it this way. And many students will hold it this way, vertically. However, what I've found in terms of visualizing circuits, it's much better to hold it horizontally. Horizontally will line up a lot better with the circuit diagrams that you draw. So to even go slightly further, there at the side there's a red line and a blue line and a red line and a blue line. These are your power and ground rails. And so I would actually recommend the way to hold it, have the, upside down, have the one near near row J, so the red plus, the one that's on the innermost, have that be up, and have the blue, which is near the letter A, have that be your bottom. And the reason for that is it allows you to make connections from your positive power rail to your circuit in the shortest distance and to your ground to your circuit in the shortest distance. Usually when you draw a circuit diagram, you think about voltage drops, and so you usually associate the top of your diagram with the positive rail, and you associate the bottom of your circuit diagram with the ground or the negative rail. So my recommendation for holding these boards is if it's facing you, have the letter A be in the bottom left corner so that you're holding it so that the red is closest to the center and the blue is closest to the center when you're looking at it. Okay, so that's the orientation that I'm going to recommend throughout the week. Now, the way that the circuit is laid out, and so yeah, I guess I'll hold it up and then eventually I'll go into a little bit more detail on the document camera. The connections for a given column, there are 5 pins that are connected. So if you look where the letters are, there's a number 1. So in that column 1, those 5 letters, F through J, those are all electrically connected, meaning if I wanted to plug something into my circuit and connect 2 objects at the same point, I can plug them into that same first column. There's a gap in between the very center of the protoboard, and what this gap does is it allows you to connect what are called dual inline packages, which are components that have pins that spread across the gap. And it allows you to electrically isolate all the different pins that you plug in. I'm going to ask for assistance. Do you have one of the spare like XOR gates or something so I can show that? Okay, so the idea of separating allows you to have separate connections for each one of those pins that are connected to your integrated circuit element. Now, when you are connecting components, you want to have, like, for example, something in a certain column and something in a different column. So for a given part, like this light-emitting diode, I would have one side of it on one column, like let's say column 5, and the other side in a different column, like column 6. I never want to connect a single component in the same column. And the reason is that you're just short-circuiting or going around that component. Because these column, like a single column, is electrically connected, you're always going to just bypass whatever that element is, and taking the element out of the circuit will be the same as having it in. So one of the errors, so I'm going to list 3 types of common errors that exist in protoboarding, is to have something plugged in where it's in the same column. That basically does nothing, so you don't want that. Okay, so this shows the protoboard, the orientation that I mentioned. So having the red, so this red row, be closest to the center. And then you have the blue closest to the center. So this is your positive rail, this is your ground rail. So I've inserted this integrated circuit across the rail, and the integrated circuit, which we'll talk about in a little bit more detail, has a certain orientation. So there's a dot and there's a circle, and I believe, but I should double check. Do you remember which side is pin 1? Mm-hmm. Okay. Yeah. Wow, this one going. Okay, so what Maddie was explaining was that for these integrated circuits, they have this semicircle, and there's also the circle to confuse you even further. But the side with the semicircle, the top left corner is pin number 1, and it's numbered 1, 2, 3, 4, 5, 6, 7, other side 8, 9, 10, 11, 12, 13, 14, going up. And each pin has a certain function. Some of these are going to take the inputs. So this is a logic gate, so it performs a certain logic operation. Each pin is going to take either an input, or it'll be an output, or it might be power or ground. So as I was mentioning,
from our perspective, it looked like you were counting from the bottom to the right.
So,
something about the image?
okay, so this is pin 1. Yeah, so I should, yeah. Okay, so, all right, so I'm mixing my 2 orientations. So this is the way I recommend holding the board. This is the way that it's typically done. So this would be the top left. Yeah, this is top left for this diagram. But I recommend holding the board and building your circuits like that. So in your parts, in the specifications and the manuals and so forth, it's going to orient the chip this way. But when you actually use the breadboard, it's recommended to orient it this way. Yeah. Okay, so different columns are electrically isolated. So if I'm inserting an LED, I would typically insert it such that it's in different columns. So you have electrical connections to different parts of the pins. I might have my battery clip, which let's say has AA batteries in it, and I have to keep track of the polarity of the LED, which side is plus and which side is minus. I could directly connect to these columns. So in this case, my red wire is connected to one leg of the LED, and let me just look at this briefly. So right now it's connected to the longer leg of the LED, and the black wire is connected to the shorter leg of the LED. So if I plugged a battery into this, this would light up. So this is a very simple way to do this. Now, as you're building a more complicated circuit, you want to use the rails. So the rails are here. So you'd plug in the plus to one rail, the negative to another rail, and then you'd have a jumper wire that would connect between, let's say, the negative rail to the negative side of the LED, and you'd have a jumper wire from the positive rail to the positive column of the LED. So that's typically how you'd use the protoboard. Now, there are three main errors that students will make. So the first thing is plugging something into nothing. So this mistake would be something like, so let's say that I have as my circuit only this, right? So in this first or let's say that I have something like this. Okay. So in this first column, where I guess this is column number 9, I only have one leg of the LED. So there's nothing connected to that. So I immediately know that that's going to be a circuit error, because almost everything, and I should say almost everything will have two things connected to it, because you're making the electrical connection. there is one exception, and we're going to do this for the FM transmitter. When you make the antenna will be an object that's only plugged in on one side. So actually, I take that back. The antenna will be connected to something else, but it'll be the only component where you don't plug in two sides of it. It only has one side that plugs in. Okay, so this is type 1 error. Type 1 error, I have something plugged into a column that's not connected to anything else into the column. Type number 2 error is plugging something into itself. So if I have two ends on the same column, then I've basically bypassed that element. And so this element is doing nothing in my circuit because the current will just flow through the electrode rather than going through the LED. And then the third thing is plugging something into the wrong thing. So let's say that I have my LED like this and I want it to light up, and I've plugged in on one side correctly, but now on the other side I've missed the column by one and I've plugged into the wrong thing. Or so maybe I have something else in here. So these errors tend to overlap. So sometimes one type of error may be something else. So let me give error number 3 correctly. Okay, so error number 3, let's say that I wanted to plug into the LED. So I should be in column 14, but let's say I'm not looking at it correctly, and so I plug in one column over. So instead of plugging it into the LED, I plug it into the IC. So that's an error number 3, where I've plugged into the wrong thing.
What about if you could show them a gap, going over across the gap to see?
Say it again.
What if you took,
yeah.
if you put it over the
Yeah.
gap?
So Anita's point is this is sort of a combination of errors, so plugging into the wrong thing. So in this case, I've plugged in on the opposite side of the gap, and these two are electrically isolated from each other, so I've plugged it into the wrong space. So this is an example where in a column, I have nothing else connected to it, and then at the bottom, I have nothing else connected to it. So if I wanted to classify it with my scheme, I would say this is an error number 1. I've plugged something into nothing.
So page 44, example B is the example of this. Is that why?
Okay, so let's go to the textbook now. So let's switch back. Okay, so let's look through the various errors. Okay, so in the text and the actual text, by the time your students receive it, the figure numbers may be different because I'm switching the order of the chapters. Let's go through example by example why these things are wrong. So in example A, and the way that you can follow this is you can trace. So in example A, you go across and you've connected 5 volts to this rail. So this entire rail is connected. This row is entirely connected. So this wire that goes to this end of the resistor is fine. I go to the other end of the resistor and I have nothing connected. So I've made type 1 error. I have something plugged into nothing. It was supposed to connect to this black wire, but this black wire is shifted by 1. So I also have the black wire connected to nothing. Okay, in this circuit, I have my 5 volts connected to this rail. I connect to this resistor. I go to the other resistor. This resistor is plugged into itself, so this resistor is plugged in the same column as itself. So this is a type 2 error. I've plugged something into itself. On the next page, so some additional errors. So this one, okay, you follow the 5 volts. It goes through this first resistor. This is plugged into a column that's shifted by 1 for this column for this other resistor. So these two are both plugged into nothing. So again, this is a type 1 error. This one, you have this resistor going, or you have the wire connected to the resistor. There's a gap, so an electrical separation between the bottom of the column and the top of the column. So this is an electrical, so this is also plugged into nothing. So this is type 1 error. And then above it, this is also type 1 error. And then this return is fine. So type 1 error because there's an electrical gap between the bottom set of columns and the top set. Okay, this one is much longer and it's incorrectly wired. So again, we follow from the 5 volts. It's connected to the rail. We go to the resistor. it goes to another resistor, goes through another jumper, goes across with the jumper, goes across with the jumper, jumper, but we've landed back into the 5 volts instead of landing back into ground. So this, essentially, this whole component of the circuit is basically plugged into itself. So this could be considered a type 2 error where we've connected all of this to itself. So this wire should go to the bottom. Now sometimes, depending on the model of board that you have, the wire, okay, so I'm going to hold this up. The boards that we have, and the reason I got this particular brand of board, the entire rail is connected. Now there are some boards that have a break halfway between, so you have like a left half of the board where the rail is connected and a right half of the board. And for those types of boards, students were constantly missing the error that they needed to connect the left and the right side. So we got boards that just have a single set. Now you actually have, because you have these different rails, you could make a circuit where you have one power rail with red and one ground rail with blue, and have a different voltage on the other red and blue. So you can actually build 2 separately powered circuits. The other type of board, you could potentially build 4 possible circuits in one board.